Okay guys, we'll start with a bit of electrical theory. There's a bit of maths involved, but we're not going to cover any of that. We're just going to go into the practical basics. We just have to accept that everything is the same, nothing changes. So we've got a conductor here. If we wrap our conductor around an iron core, a bolt, and we pass 12 volts in, 12 volts out of our conductor. Within our iron core we're going to induce magnetism or flux. Now this flux will change direction depending on whether we put the 12 volts in here or put the 12 volts in this end. And this magnetic flux too will change its magnitude depending on how many coils of wire we have and the current that we pass through our coils of wire. Each end of this bolt or iron core would have a north and a south pole. Now if we take a conductor, another piece of wire, and we pass our conductor through this magnetic flux, we're going to excite the electrons within this wire. They're going to want to move. So this potential of electron movement is known as voltage. So passing a conductor through a changing magnetic force, we're going to induce a voltage into our conductor. So what we have here is exactly the same as what we have here, an electromagnet with coils of wire wrapped around an iron core. Now on our motorcycle we would have DC applied to this electromagnet. At this point there's no magnetism there. We take 12 volts off our motorcycle battery, put it to our rotor, we have a magnet. Now it doesn't matter which way we put this, it's still a magnet, the poles just change. So depending on the direction of our 12 volts, we'd have a north-south, north-south, or if we put it the other way around, we're going to have a south-north, south-north magnet. Now the downside with having an electromagnet like this, you need an external power source to get the bike running initially. That's why you have a battery. You can get permanent magnet alternators. This would be my choice on a bike. In fact, this one's going to be a permanent magnet alternator. You can run it then without a battery, just a small capacitor or a small battery. So we've got 12 volts in, 12 volts out, we've got a magnet, then we've got a conductor which is our stator. We've actually got three conductors, three coils of wire in groups of three wrapped around laminated iron cores, which again is just like our bolt. So remember, we pass a DC current through this, we gain a magnet, we get another conductor, we pass it over the magnet, magnetic flux induces a voltage within our wire. So exactly the same thing happens here. Voltage induces a magnetism induces a voltage within our coils of wire. So coils of wire come to our plug. We've got three coils of wire, we've got three ends, and then those three ends are connected at a central point called a star. That's a star configuration. Our three wires come off our rotor to our terminal strip. We have a fourth pin which is a grounds to the motorcycle, All voltage systems need a ground or a 0 volts reference point. If you don't have a reference point, your voltages float, your voltages aren't regular. Then our next two pins, they're our DC for our rotor. So DC in, rotor spins on the crank, induced voltage within our stator creates another voltage, ends up at our pins right here. So this is where it gets interesting. Now, do this with my keys all the time, put them down and 30 seconds later I've lost them. So our 0 reference point, call that 0, like that, that's our 0 volts. So our conductor is passing over our iron core. In between the two is 0 volts. It approaches one of our poles, so the voltage rises. Note the way these are shaped, so it doesn't hit it all at once, it hits it gradually. So the magnetic flux induces that voltage, the voltage rises. As it gets to the center of the magnet, this is its peak, then it drops off, comes down the other way till it's back in the center, 0 volts again. Then it hits the opposite pole, the magnetic flux is going in the other direction, the voltage in turn wants to change direction, so our potential of our voltage changes. So then it goes the other way, hits its peak, comes down the other side, the crest, and then back to 0 volts. It just goes round and round and round, so we end up with a waveform that looks like that. So that alternating waveform, one to the other, is our AC current. But remember, we have 3 of these, so we've got 3 voltages and they're offset. So that's our second one, and our third one would look something like that. So that's our 3-phase alternating system. Now, what can go wrong with this? Well, we can get a break in our wires here. First place to look for if your motorcycle is not charging would be perhaps do an ohms test on your rotor. Now, every motorcycle is going to be different. They'll be similar but not identical. So it would probably help if you knew what your rotor should be, a good rotor should be on your bike, so you've got something to compare it to at some point. They don't often fail, but they can. If you've got an open circuit, it's going to be easy to tell. You're going to have nothing there. If you've got a short circuit, well, that's going to be easy to tell. You're going to have low ohms, but you might have a short circuit 3/4 of the way through or near the end, so you may get 2 short circuits. You may just cut out a small part of the winding, so your ohms may be half of what they should be. So that, of course, is going to affect your current through the rotor, and that's going to change your magnetism on the magnets, which in turn will change your AC magnetism voltage out. That, of course, could affect the way your battery is charging. You may not get 12 volts, normally a normal motorcycle charging circuit will be about 13.2. You may not get that, you may get more, you may get less. Now, what else can go wrong? Of course, you can get a break or a short in any of these wires here. Again, do an ohms test across your 3 wires, 4 wires. You'll get the same reading across those 3, and then your 4th one, you'll get the same reading across all 3. It'll be slightly less, it may not be half, but it could be half. So 3 wires, do your ohms test, check that you've got a circuit on all those wires. Now, you may say, well, that's all well and good, I don't have a alternating charging circuit on my motorcycle, I've got a DC. Most bikes are 12 volt, there's still a few 6 volts floating around, never seen a 24. So that's the job of the regulator rectifier, to change this AC sine wave into 12 volts. Keep watching the next video and we'll go to detail on that. That's it. Thanks for watching.